Rate law. Rate is proportional to the concentration of the reactants or catalysts, also known as K times those concentrations. What is K? It is a slope. Y, well, let's have a look at this graph over here. This is a concentration over time graph. So at time is equal to 0, it's Y over X. So your slope is going to be Y over X here. Again, this is the Y-axis, this is the time, X-axis. So you just divide them. So you just get change of concentration over the change in time. That's equivalent as well. Now let's look at this over here. Our initial rate at time is equal to 0 right there. Again, this is where our slope that we found. Okay, but we can isolate for y. So you just multiply by x on both sides. You do it on the right side, you have to do it on the left side. Now y is equal to your actual rate, because initial rate is at time is equal to 0. X is your time. As it progresses, it's no longer going to be initial when you multiply them as a product, so you actually get rate. Next, we have a first order reaction. If it's to the power of 1 in that particular formula, this is a first order. If it's to the power of 2, it's going to be a second order. We have to know these formulas over here in order to do these questions. Please memorize it. See the 20-minute video for an in-depth look. Now let's look at A. Your reactance is going to be proportional to your rate. So if this is going to be doubled, proportional, this has to be doubled as well. So the answer would be doubled. Next, we have B. Okay, what is the formation of Z in trial number 3? Let's look for trial 3. Let's look for Z. We don't have Z. We only have rate of Y, but it's okay. Let's write that down. So we have 80 moles per liter per second. Okay, diagonally, they are going to be the same. So I've written out this way that they can cancel out. Okay, for every 2Y, there's going to be 1 Z. Okay, as written over here. Okay, so it's going to be a 1/2 ratio. That's half. So you just multiply them. You end up getting 40. Next, we're looking at C. What is the rate of disappearance of C in trial number 2? So we're in trial number 2 over here. Okay, again, we're looking for C, right? So we only have rate of Y though, so let's written out this way as such, and we're going to again multiply it diagonally so that they can cancel out, but we're trying to look for C, right? The question that says is the disappearance of C, so we know that the ratio is going to be 3/2, right? Because we have 3 C's for every 2 Y's, so you just multiply them times 1.5, you end up getting 22.5. For D over here, what is the rate law derived? Okay, you have to use these formulas over here. So you have to look for the different initial concentrations that are the same. So this here is the same, this here is the same, but this is different. That's perfect. So if you have 1 out of 3 that we cannot find, that's what we're going to be using in order to find our exponents. Okay, so we're just going to use trial number 2 and trial number 1. I've written it out here as such. You just divide them using this formula over here. You end up getting 1.5 is equal to 1.5 to the power of n, and is equal to 1. So I've written out as here as such. Do the same thing for m and then o. So this is the exponent of m and o. So you end up just getting 2, 1, 1. You try it yourself on your own. So I've written it out here as such in the general formula. That is the answer for the rate law. Next, we have E. What is the missing rate for trial number 5? We can't do it unless we have our K. So I'm going to look for K over here. I've written it out over here. I've used any single trial. It doesn't matter which one you use. And I've used the exponents that we found over here. I end up getting 1,250,000. With that K, you can put it into this trial number 5 using this general formula. You end up getting 2.5.